Good morning, Williams class. For your maths lesson today, the arithmetic is up on the screen for you. So go ahead and pause this video and have a go at doing the arithmetic and unpause when you are ready to move on. Our learning objective for today is, can I solve correspondence problems? So what you are expected to understand by the end of the lesson is to find all possible combinations of two groups of items and also to use multiplication facts to help you. We are going to start with a 2-minute challenge. So using only these digit cards and a maximum of 2 multiplication symbols, how many different totals can you make? The digits that are available to you are 5, 3, and 2. You can only use the times symbol twice, no more than twice. So for example, one sum you could have is 5 times 3 times 2, where the multiplication symbol has just been used 2 times. So have a go, 2 minutes now to come up with as many combinations as you can think of. So correspondence problems are where a certain amount of objects are connected to another amount. In this problem, we have 2 types of bread connected to 3 types of filling. The goal is to find out all possibilities. We will do this example together. A canteen has 2 types of bread and a choice of 3 sandwich fillings. So the bread options are white, brown, you also have cheese, tuna, and chicken as your fillings. So what we have to do here is list the different sandwiches that can be made. Now, one has been done for you, cheese on white. So you can have cheese on white bread. Another type of combination you could have is cheese on brown bread. Just like we've got cheese on white, you can have cheese on brown. So I'm just going to write that for you here. Cheese on brown. You could also have maybe tuna on white. Tuna on white. And then you could have tuna on brown bread. So really just starting to think about the different ways in which you can have your sandwich. Now, we haven't finished coming up with our combinations yet. We've done cheese on white bread and cheese on brown bread. We've got tuna on white bread and tuna on brown bread. What's left? What filling is left that we haven't yet combined with a bread type? Chicken. So we can have chicken on what sort of bread? We can have chicken on white bread. Fantastic if you were shouting that out at home. Now we can have chicken on white bread or we can have chicken on brown bread. So I'm just going to write that down. Chicken on brown. So let's go on to B. We have complete the multiplication to represent the number of different combinations of bread and filling. So how many different combinations do we have there? We have 1, 2, 3, 4, 5, and 6 different combinations. Now, the way to work this out is to see how many bread types we have. So how many bread types do we have? We have 1 here and 1 here. So we have 2. So I'm going to write 2 there. And then how many types of fillings do we have? We have 1 filling here, 1 filling here, and 1 filling there. So in total, that is 3 fillings. And then you multiply those 2 numbers together. So what's 2 times 3? If you said 6, well done. So now we're going to complete the sentence. There are how many different combinations? 6. So how many combinations would there be if there were 4 choices of sandwich fillings? So back to our question then. How many bread types do we have? We have 2. And this is asking us if there were 4 choices instead of 3. So I'm going to write 4 there. Now the way to work it out is exactly the same as we worked it out for part B. You do 2 times 4 because there are 2 bread types and there are 4 fillings. So what's 2 times 4? 8. So all in all, there would be 8 combinations, just like that. Let's try this one together. A pizzeria offers a choice of bases and toppings. So the pizza bases that we have are deep pan and thin, and the toppings we have are mushrooms, chicken, onion, peppers, and sweet corn. So we have to complete the multiplication to work out how many different combinations of pizza there are. So I'm going to take my pen and I'm going to see how many different pizza bases we have. So we have one here and two here. So in total, we have 2 pizza bases. And then how many toppings do I have? 1, 2, 3, 4, and 5. So 5 different toppings there. Work that out. What is 2 times 5? We have 10. So complete the sentence. There are 10 combinations of pizza. So remember, the way to work out how many different combinations of pizza you can have, you just multiply the option here by the option here. So you multiply the number of pizza bases, which is 2, by the number of toppings, which is 5. Multiply those 2 numbers together and you will get your total number of combinations there. So now it is your turn. I would like for you to pause the video at each slide and complete the questions. And afterwards, I will then go through the answers with you. Good luck. So I'll read out the question for you just so you can hear how it sounds. Mo visits the fun fair. He buys a ticket that allows him to choose 1 ride and 1 game at the fair. So part A, is Mo correct? He says that there are 8 different possible choices of rides and games. Then you have to explain your answer. B, list all the different choices Mo can make. And then you just write in the box how many choices he can make. So pause this video now, have a go. When you unpause, we will go through the answer together. Okay, so let's go through it together. Mo says there are 8 different possible choices of rides and games. Is he correct? Let's see if there are 8 possible. Calculate how many rides we have altogether. 1, 2, and 3. So I'm going to write 3 there. And how many games do we have? 1, 2, 3, 4, 5. 5 games there. So remember, the rides are Big Dipper, Dodgems, and the Carousel. The games are Hook a Duck, Basketball, Coconut Shy, Lucky Dip, and Test Your Strength. Now remember the way to work out our different combinations. We multiply those 2 numbers together. So what is 3 times 5? 15. So Mo says there are 8 different possible choices, but we've calculated actually that there are 15. So is Mo correct? No. Explain your answer. And then here you could just write the calculation. And then you could write maybe here, there are 15 choices. And then comma, not 8. Remember to end with a full stop. Now list all the different choices Mo can make. So here you have to write all the different choices that he can make. So we have Big Dipper and Hook a Duck. What other ones do we have? We have Big Dipper and Basketball. So rather than me just write out Big Dipper again, I'm just going to write the choice that he has with it. What else can he play with Big Dipper? We have Coconut Shy. Coconut Shy. He could also play Big Dipper. He could also ride Big Dipper and play Lucky Dip. And then the last game he could play with Big Dipper is Test Your Strength. Now, I don't have space to write all of the different possible choices, but you will hopefully have enough space when you are writing this by yourselves at home. So what did we calculate then? How many different choices can Mo make? Remember the multiplication we did? 15. So well done if you got that at home. The next question to do is, Aisha has 3 headbands and 5 hair slides. Kim has 2 headbands and 6 hair slides. Who has more choices of combinations for wearing 1 headband and 1 slide? Now, it does say you can talk about it with a partner. So if you want to talk about it with another adult or another person in your family, then you're more than welcome to do so. Pause this video, have a go, and then when you unpause, we will go through this together. Okay, So Aisha has 3 headbands and 5 hair slides, and then Kim has 2 headbands and 6 hair slides. So the first thing that I want to do is see how many combinations they have individually. So how many possible combinations could Aisha have, and then how many possible combinations can Kim have? So in order to do that, I'm going to see how many headbands she has and how many hair slides she has. So she has 3 headbands and 5 hair slides. So I'm going to multiply them together. 3 times 5. What is 3 times 5? 15. So Aisha has 15 possible combinations. Let's see how many combinations Kim has. So she has 2 headbands and 6 hair slides. So we're going to multiply them together to work out how many different ways Kim can style her hair. So 2 times 6 would be 12. So Aisha has 15 different possible choices and Kim has 12 different possible choices. So who has more choices then? The answer would be Aisha. So well done if you managed to get that correct at home. It shows me that you are understanding the correspondence problems. Next question. Here are the activity choices available at summer camp. So you have 3 different types of sport activities there. You have arts and crafts and you have outward bound. So football, tennis, golf, the sport that's available. The arts and crafts that are available are painting, pottery, mosaics, and origami. And outward bound means anything to do with wall climbing, kayaking, and abseiling. So each child is allowed to choose 3 activities per day. 1 sport, 1 arts and crafts, and 1 outward bound. How many activity combinations are there? And then part B says, due to a flooded pitch, football is cancelled. How many combinations are now possible? Pause the video, have a go, and when you unpause, we will go through it together. Right, so let's do this together then. It says here that each child is allowed to choose 3 activities per day, 1 sport, 1 arts and crafts, and 1 outward bound. How many activity combinations are there? So I'm going to calculate how many sports are available. How much sport is available? In total, it would be 3, football, tennis, and golf. So 3 altogether. I'm going to write 3 there. Arts and crafts, how many available? Painting, pottery, mosaics, origami. So that's 4 in total. And then outward bound, how many available? Wall climbing, kayaking, and abseiling. That's 3 available altogether. So to work out how many activity combinations there are, you multiply those numbers together. So you do 3 times 4 times 3. And what does that equal? Let's do 3 times 4 first. 3 times 4 would be 12, and then you do times 3. So remember, your 12 times tables or your 3 times tables, knowing them 2 would come in handy for this answer or for this calculation. What's 12 times 3? 36. So the activity combinations that would be available are 36. Part B says that football has been cancelled, so there's no more football. So I'm going to cross that out because we don't need that anymore. Now, how many combinations are possible? So now that football's been taken away, I need to recalculate how many possible combinations there are because we don't have 3 types of sport available anymore. We only have 2. So work it out exactly the same way, just with different numbers. We have 2 times 4 because there are 4 arts and crafts available and 3 outward bound. So 2 times 4 times 3. Now remember, work at it one at a time. What's 2 times 4? 8. And then times 3. What's 8 times 3? 24. So now, because football's been cancelled, instead of there being 36 different combinations, we now have 24 combinations. The next one, Tom and Esther are building a snowman. They have a choice of 5 hats, 4 scarves, and 2 pairs of gloves to dress their snowman. How many different combinations are possible? Pause this video and have a go. Right, so let's work through this together. They have a choice of 5 hats, 4 scarves, and 2 pairs of gloves to dress their snowman. So how many different ways can they dress their snowman? What we have to do is just take each number and multiply all together. So what are my 3 numbers then? I have 5 for 5 hats, I have 4 scarves, and 2 pairs of gloves. So I have to multiply together 5, 4, and 2. So what's 5 times 4 times 2? I'm going to do 5 times 4 first, which is 20. And then I'm going to do 20 times 2, which is 40. So I'm going to write the answer there. So all in all then, there are 40 combinations. So well done on your maths work this lesson, Williams class. I really hope that me breaking it down question by question helped you. If you have any questions or concerns or anything to add, then feel free to drop a message onto Tapestry or save it for a live session or email me. I'll see you very soon, Williams class. Take care. Bye.